Using an oil seal puller here to remove the input seal. The main casing has two bearing races, one for the input gear and another for the differential. Now I'm using just a punch here with a sledgehammer. Sorry about the camera, it's decided to wander. These two bearing races are not the same. One is thinner than the other, so we want to make sure you remember which one goes where. For the input gear, it's a Timken 18720, made in France. For the other side, it's a Timken JLM 104910, made in the USA. Onto the front output housing, we can knock the shaft out with a copper hammer.
The flat edge comes up to the teeth.
These oil seals can be in pretty tight. I found that a lady slipper works the best to get these out. Now using a pair of 8-inch circlip pliers to get the circlip out. We'll need to remove this in order to punch out the bearing. Flip the housing over and we will tap out the bearing with a punch. It's helpful to support it with some blocks of plywood. And finally, there's a bearing race that we'll punch out as well. There's a spacer in there. There's also a shim in there with the bearing, so you want to keep these together, and we'll have to experiment on the rebuild onto which shim will work the best. It's kind of annoying because we'll have to punch this bearing in and out again. Got a Timken here, Y32011XM, made in Poland. Concave, faces inwards. Moving on to the rear output housing, we'll tap the shaft down with a copper hammer. Give it a couple good whacks. And from here on out, it's pretty much the same as the front. We'll pull the seal out. We'll take the circlip out and punch out the bearing and bearing brace. Bearing here. This one, the lettering was facing inside. Now we're moving on to the main shaft input gear bearing housing. I want to mark this to make sure that it'll go back on the same way it went. Just using a scratch awl to make a marking. This bearing race has a shim in it as well. So you want to keep those together in a bag and tag. Time to dismantle the differential. I've got a special tool here from Ashcroft. It's a socket that fits onto that nut. Now with the differential flipped over, we're going to pull off this bearing here with a 3-job puller. I'm also using a steel disc that I bought from McMaster Car. Now before we separate these differential carrier halves, we'll want to check on the casing to see if there's an existing marking that will allow us to align the carrier back to how it was assembled originally. And you'll see here on this carrier that there's 2 punch marks in there on the casing. So just keep that in mind. We'll remember to assemble that back together. With the top half of the carrier removed, we now can see the planetary gears and the sun gears on the top and bottom. There's copper thrust washers on each side of the planetary gears. So check to make sure they're still there. If they're gone, then this carrier might be non-serviceable. And if you're going to not replace the gears, you want to keep them in their exact fitted order. But since I'll be fitting a new HD cross pin and new gears, I can just pull them out. Now behind each sun gear there's going to be a thrust washer. There are different sizes here, so we're going to replace the thrust washer anyways. I recommend to buy a kit with a bunch of different sizes so we can set the preload correctly. Now taking the differential to the press, we're using a ball socket adapter here that fits over the shaft. And now the only thing that's pressed onto the shaft here is the bearing raise at the top. So what we're going to do is we're just going to press the whole shaft downwards, and we're using the arbor plates to support the low range gear. That way the shaft can move freely, make sure the shaft is supported on the underside so it doesn't fall out. And as we apply pressure, it might not move at first. Just apply it nice and slowly. Fortunately, right here, I sort of made a loud noise. I think that was just breaking free a little bit. I checked later for any sort of damage, and I didn't see any. It's a little bit concerned here at the moment. Now trying again. This time the shaft will move nice and smoothly out. With the bearing removed, we're now free to remove the rest of the components off the shaft. Here's the high range gear. There's a hub here that fits in the middle. Pulling it out as a unit, you see the hub there in the center. Just checking it over quickly for any obvious signs of wear. This case only has about 50,000 miles on it, so these components look pretty good, but I will be replacing this high range gear with a 1.41 spec keepers. Now we have the high-low selector hub. Try and keep this in its fitted order. I don't think the direction matters so much, but we want to keep the splines there in the same position. And finally, we'll pull off the low range gear. This rides on the shaft by itself. There's no hub or sleeve here. So that concludes the teardown. I'm not going to be pulling the bearings off the input gear or the bearing races out of the intermediate gear because I'll actually be replacing both those units. I need to in order to fit the new high range gear, so there's no point really to knock those out.